In this unguided media, we have three different categories: radio waves, microwaves, and the C and D comes under the based on light. One is infrared type, and the second one is light wave transmission. So radio waves means it's having a very wide range, starting from 30 Hz to 300 GHz is considered as a radio wave spectrum. So that it travel longer distances at low frequencies. Radio waves pass through obstacles well and penetrate through buildings very easily. Radio waves are frequency dependent. The power falls off sharply with distance from the source, roughly as 1 by r square in air. And these radio waves are used for our most of our radios. So that's why the reason you can listen radios from other continents also, which are broadcasted in other continents also. And if you look into the way radio wave applications, you have radio, TV, mobile phones, electronic gadget remotes, wireless keyboards, mouse, etc. All these things they use radio waves. And next, microwaves. Microwave supports from 300 MHz to 300 GHz. See, actually, the microwave bandwidth also falls in the radio wave spectrum. The only difference is when you go to higher frequencies, they start traveling in a straight lines. So all this microwave, it comes under this category. So microwave travel in nearly straight lines and can therefore be narrowly focused. This directionality allows nearby microwave equipment to use the same frequencies with multiple transmitters and receivers in a row without interference because they don't interfere to each other since they're traveling in a straight line. Something like eyesight. So example is you can see the dish TV and cellular telephones, etc. Dish TV, you can understand why dish TV should be focused to the angle of satellite, which are normally they put it on the roof, on the top of the houses. And microwaves do not pass through buildings well. It is weather and frequency dependent, affected greatly by environment constraints, including rain fade. So one simple example is normally we see too cloudy and you start getting some sort of missing of frames in your TV. So that is because this is microwaves are very much they affect due to moisture and rain droplets due to it can be diffraction or diffraction. So it's a mostly affected by the environment. And then comes infrared waves. Infrared waves are used for short range communication. For example, remote controls. They are relatively directional, cheap, and easy to build. An advantage is infrared system will not interfere with a similar system in other buildings. Security of infrared systems against eavesdropping is better than the radar systems. But the disadvantage is infrared waves do not pass through solid walls, whereas radio wave passes. Now, coming to the light wave transmission. It can connect the lands in two buildings via lasers mounted on the rooftops. Each building needs its own laser and its own photodetector. And the advantage is it offers very high bandwidth at very low cost. Relatively easy to install and unlike microwave does not require any license. And the disadvantage is laser beams cannot penetrate through rain or thick fog. They normally work well on sunny days. Even heat from the sun causes convection currents to rise up from the roof of the buildings, causing turbulent air diverted the beam around the detector. So all these things are the negative points. They can disturb the light ray, laser beam. Part 2, communication satellites. A communication satellite can be thought of as a big microwave repeater in the sky. It amplifies the incoming signal and then rebroadcasts it on another frequency to avoid interference with the incoming signal. So the incoming signal has a different frequency and the outgoing signal has a different frequency. And these are the three orbits: LEO, MEO, and GEO. And LEO is a say for from it is between 0 to around 600, and then comes the MEO orbit, and over that at 35,000 kilometers you'll see the GEO. We'll see in detail. So geosatellites are in orbit 35,076 kilometers above the Earth's surface along the equator. Now, why they put at that distance exactly, over nearly closely? Because they're the speed of the Earth. It revolves around the Earth at the same speed as the Earth rotates and remain in the same position relative to the surface of the Earth. So this is the advantage. And all these TV transmissions, they go for geosatellites. The advantage is a geosatellite covers a large area footprint of the Earth's surface. A matter of fact, 3 geosatellites are sufficient to cover the entire Earth. And geosatellites have a 24-hour view, make it ideal for satellite broadcast and other multi-point applications. If you look into the disadvantages, a geosatellite distance from Earth causes signal weak and time delay in the signal since it's traveling longer distances. So there will be more attenuation as well as delay in the signal. It have difficulty broadcasting signals to near polar regions. Then comes MEO or medium Earth orbit satellites. A MEO satellite is in orbit between 8,000 to 18,000 kilometers above the Earth's surface. MEO satellites are visible usually between 2 to 8 hours. And the advantage is longer duration of visibility and wider footprint means fewer satellites are needed in a MEO network rather than a LEO network. But GEO, it covers only three, as I told you, GEO, 3 satellites sufficient to cover the entire Earth. In case of MEO, you need more. And in case of LEO, you need much more. So the disadvantage is a MEO satellite distance gives it a longer time delay than a weaker signal than a LEO satellite. But it is better than GEO when compared to time delay. And GPS, which is very popular, is known as Global Positioning System. One example of MEO satellite system is the Global Positioning System (GPS), positioned to the altitude of 18,000 kilometers above the Earth. And this GPS uses 24 satellites in 6 orbits. The orbits and the locations of the satellites in each orbit are designed such a way that at any time 4 satellites are visible from any point on Earth. So it requires minimum 24 satellites. In case of GEO, it's 3. Next comes the low Earth orbit satellites. LEO satellites has polar orbits. LEO satellites are much closer to the Earth than GEO satellites, ranging from 500 to 1500 kilometers above the surface. LEO satellites don't stay in a fixed position and are only visible for 15 to 20 minutes for each pass. The advantage is its proximity to Earth gives it a better signal strength and less time delay because it's closer to the surface, which makes it better for point-to-point communications. And since LEO satellites covers only small area of coverage, is less of waste of bandwidth. If you look at the footprint, it's having a very small footprint. And the disadvantage is a network of LEO satellites is needed, which can be costly. With a less number of LEO satellites, you can't cover the entire surface. And atmospheric drag affects LEO satellites, causing gradual orbital deterioration. And one of the best example is Iridium system. Iridium system has 66 satellites divided in 6 orbits with 11 satellites in each orbit. The interesting part is when they first initialized to this Iridium system, they thought theoretically 77 satellites are required. So 77 is the atomic number of Iridium if you look into the periodic table. So basing on that, they named this constellation as Iridium system. But later they found 66 satellites are sufficient in 6 orbits and with 11 satellites in each orbit. The orbits are at a altitude of 750 kilometers. Even though technically it's a great success, commercially it failed, the Iridium system.